Hi everyone, today let's learn to do some integration for rational functions. At the end of this lesson, you should be able to solve the integration of rational function by using partial fraction. The integral by partial fraction is actually based on the partial decomposition methods. What is partial decomposition method? Well, let's look at some example. Let's say we have 1/3 plus 1/4. So what is the answer? Actually, in order to solve this type of fraction, we actually need to multiply something so that the denominator will be equal. And then we get 1 multiplied by 4 over 3 multiplied by 4 plus 1 multiplied by 3 over 4 multiplied by 3. And then, as we can see, we get 4 over 12 plus 3 over 12. And then we get 7 over 12. Inversely, we can also say that 7 over 12 is equal to 1/3 plus 1/4. So this is called a partial decomposition method. We will use this method in order to solve some of rational function to integrate it later on. Here is the table of partial fraction for rational function. As you can see, as listed in the table, there are several types of proper rational function that can actually convert into partial fraction. Let's see at this first one first. So we have the polynomial px plus q over x minus a, x minus b, which is the linear product. So actually we can convert into separate two term, which is a over x minus a plus b over x minus b. Number 2, let's say we have a polynomial over triple product of linear. So we have a over x minus a plus b over x minus b plus c over x minus c. At the third one here, we have polynomial over some linear to the power of 3. So let's say at the denominator we have power like this. So actually we need to write a repetitive linear increasing order of power. So we have a over x minus a to the power of 1 plus b over x minus a to the power of 2 plus c over x minus a to the power of 3. And then let's say at number 4 here we have polynomial over some linear product where one or some of it have the power. So we have to write like this: a x minus a plus b over x minus a square, which is increasing order of degree, and then plus another linear, which is c over x minus b. And then at number 5 here, let's say it's a product of a quadratic function and a linear function at the denominator. So we have to write it separately, which is a over x minus a. But at the quadratic function, at the numerator, we can actually write is as bx plus c over the quadratic function. So lastly, if we have the product of quadratic function at the denominator, so we have to write it as ax plus b over quadratic function and then plus cx plus d over quadratic function. Now, let's learn how to set up the partial fraction. Let's say we have this rational function of 8x plus 8 over x in bracket x squared minus 4. So in order to solve this, we need to try to factorize at the denominator first. Then we'll get at the denominator as x in bracket x plus 2 in bracket x minus 2. So by looking at the partial fraction table, so we know that we have to separate that into 3 terms. So we get a over x plus b over x plus 2 plus c over x minus 2. Okay, now let's look at another example. This is improper rational function. Why is it so? It is because the higher degree at the numerator is higher than the higher degree at the denominator. So we know that this is improper. So we can't directly use the partial fraction table for this improper rational function. So For this case, we have to do the long division to reduce the numerator, and it will become the proper rational function. So let's do the long division first. So we try to multiply x squared minus 2x minus 3, and then we get 2x multiplied by x squared minus 2x minus 3. We will get 2x cubed minus 4x squared minus 6x. Then we subtract this part, then we will get the remainder of negative 7x squared plus 25x plus 8. Okay, and then we have to multiply by negative 7 with x squared minus 2x minus 3. Then we will get negative 7x squared plus 14x plus 21. Then we subtract this part, then we get the remainder of 11x minus 13. Now we have mixed rational function for this part. Then we get 2x minus 7 plus the remainder of 11x minus 13 over x squared minus 2x minus 3. So you notice that we have 2x minus 7. We ignore that part because later on we easily can integrate it. So we just focus on the part where there is a proper rational function, because at this part is where we refer to the partial fraction table. Okay, now at this part we try to factorize at the denominator, then we get x minus 3, x plus 1. Okay, so by using the table, so we now get 2x minus 7 plus a over x minus 3 plus b over x plus 1. So that's it, how to solve, how to set up the partial fraction for rational function. Now, let's look at example 13. Evaluate the integral of negative 2x minus 14 over x squared minus x minus 2. So at first, we need to do the factorization at denominator. Then we will get denominator as x plus 1, x minus 2. And then by looking at the table, we know that it is a over x plus 1 plus b over x minus 2. Okay, to solve, before we do the integration, we have to solve the value of a and b. So we have to make all the partial fraction become the same denominator, equal denominator. So we have to multiply with certain linear function so that it is equal at denominator. So we get like this. And then we take out all the numerator. Then we get a in bracket x minus 2 plus b in bracket x plus 1 is equal to negative 2x minus 14. And then we expand, and we get ax minus 2a plus bx plus b is equal to negative 2x minus 14. And then we separate it into coefficient that have x and does not have x. And then we can actually see that a plus b is equal to negative 2 for coefficient x. And then we have negative 2a plus b is equal to negative 14. So we have to solve this simultaneously to get the value of a and b. And then we substitute b inside the second equation. Then we get a is equal to 4 and b is equal to negative 6. And then we try to substitute the value of a and b inside the integral. So we get the integral of 4 over x plus 1 minus 6 over x minus 2 dx. So by looking at the integral properties table, so the final answer for this integral, we get 4 ln x plus 1 minus 6 ln x minus 2 plus c. Let's move to exercise 14. Evaluate the integral of x minus 3 over x squared in bracket x plus 1. So at the denominator here, we have the product where one of it is the power. So when one of the product, linear product, we have the power, so we have to write the partial fraction at that part with increasing power at the denominator, such that a over x plus b over x squared. And then for another product, for a linear factor there, which is x plus 1, we just plus c over x plus 1. And then we try to equal all the denominator by multiplying something. Okay, and then we get like this. And we take out all the numerator, then equal it into left hand side and equal to right hand side. and then expand it, we get ax squared plus ax plus bx plus b plus cx squared is equal to x minus 3. And then we separate it into the coefficient, where we have x squared, x, and the constant. So for coefficient x squared, we separate and we get a plus c. So at the coefficient x, we get ax plus bx is equal to x. So where it's actually a plus b is equal to 1, and the constant we get b is equal to -3. So since that we have b value, so now we try to solve a and c value. So we get a is equal to 4, c is equal to -4. And then try to substitute all the value of a, b, and c inside the integral. Then we get the integral of 4 over x minus 3 over x squared minus 4 over x plus 1 dx. And then simplify it and then solve the integral. Then we get 4 ln x plus 3 over x plus 4 ln x plus 1 plus c. That's all from today for the integration rational function by partial fraction. So let's check your comprehension.